light waves coming out of two coherent sources, principal quantum number n has to be calculated. It has nothing to do with an obstacle, with the path of light. It does not depend upon magnetic field in which it lies. Then what will be the direction of the induced current? The next problem, Young's double slit experiment. We are performing Young's double slit experiment, which gives interference fringes of width 0.3 millimeters. Fringe width kottidare, beta kottidare 0.3 millimeter. A thin glass plate of refractive index 1.5 is in the path of light from one of the slits. Then what happens to the fringe width? Dear students, the problem says in Young's double slit experiment, fringes of width 0.3 millimeter is obtained. Now a very thin glass plate of refractive index 1.5 is kept in the path of light from one of the slit. Then what happens to fringe width? We know fringe width beta is lambda d by d. It depends upon wavelength of light, distance between the source and the screen, distance between the slits. It has nothing to do with an obstacle, with the path of light. So fringe width remains the same, which is 0.3 millimeters. Now, near a circular loop, there is a circular loop of conducting wire is as shown. The electron is moving along a straight line. Then what will be the direction of the induced current? ನೀವು diagram na nodidre makla, the electron is moving from left to right with respect to this loop. So here the electron moves from left to right with respect to the loop. Which means here what happens? The flux first decreases and then increases. The magnetic flux across the loop first decreases and then increases. So the current is from clockwise to anti-clockwise, which means the direction of current is variable. Next, an hydrogen atom from an excited state, some excited state I call as N, comes to the ground state, N is equal to 1. So from the excited state, the hydrogen atom is coming to the ground state by emitting a photon of wavelength lambda. He says R is the Rydberg's constant. Principal quantum number N has to be calculated. Now, here N1 is 1, N2 is N. From some excited state, it comes to the ground state. N1 is 1, N2 is N. And we know 1 by lambda is R, 1 by N1 square minus 1 by N2 square. ಈಗ ಈ R ನ ಡಿನಾಮಿನೇಟರ್ ತಗೋ ಬರ್ತೀನಿ. I bring R to the denominator. 1 by lambda R is 1 by N square is 1 minus 1 by N2 square. N, this is 1 by 1. Or this becomes 1 minus 1 by lambda R is 1 by N square. Or lambda R minus 1 divided by lambda R is 1 by N square. So N is root lambda R divided by lambda R minus 1. So the third or the fourth option is the correct one. Magnetic dipole moment is independent of magnetic dipole moment. I, N, A depends on number of turns. Yes. Depends on area. Yes. Depends on current. Yes. It does not depend upon magnetic field in which it lies. Ruby laser, previous syllabus again. Stimulated emission is due to transmission from metastable state to ground state. Characteristic of lasers. Unlike the other elements, here the atoms directly from the excited state don't come to the ground state. For the working of a laser, the ions or atoms first come to a metastable state, in between state between the excited and the ground, and then it goes to the ground state. Direct current I flows through the length of infinitely long straight wire, then the magnetic field is 0 along the axis of the pipe. Again, an assignment which is very famous with lens maker's formula. Please use your lens maker's formula. We will arrive at the answer. Two sources are said to be coherent if they produce waves. What are coherent waves? Same frequency, same wavelength, constant phase difference. The light waves coming out of two coherent sources should have constant phase difference. Again, I have worked out this series or arrangement of resistors using branch current formula. Find the resistance. Common emitter amplifier. The input signal is across the emitter base junction. In a radioactive disintegration, the ratio of initial number of atoms to the number of atoms present at an instant of time. Ratio of initial number of atoms to the number of atoms present at a given time. I refer to radioactive decay law. N equals N naught e to the power minus lambda t. ಇದನ್ನ ರೇಡಿಯೋ ಆಕ್ಟಿವ್ ಡಿಕೆ ಲಾ ಅಂತ ಕರಿತೀವಿ. Now, n equals n naught e to the power minus lambda. I substitute t is 1 by lambda, definition of decay constant, reciprocal of time. So n is n naught e to the power minus 1. So ratio of initial number of atoms to the number of atoms that remain is E. Again, conceptual, lateral shift. So the angle of refraction will be tan inverse 1 minus root 2 divided by 3. Ferromagnetic materials used in a transformer, they have high permeability and low hysteresis loss. Here, power loss should not happen due to hysteresis. So, low hysteresis loss. According to Newton's corpuscular theory, speed of light is lesser in denser medium. For constructive interference, they're all theory based, no calculations. If you know your theory at the surface, very easy, n lambda. Accurate measurement of EMF can be obtained using potentiometer. Why? Potentiometer will not draw current from the source. Voltmeter draws current from the source. Potentiometer will not draw any current. Therefore, it measures EMF accurately. Kinetic energy of an electron gets tripled. Then what happens to de Broglie wavelength? We know de Broglie wavelength is h divided by root 2m E, so it is proportional to 1 by root of E. Now lambda dash, this is root 3 times E. So when you take the ratio, 1 by root 3 should be the answer. Which of the following is not a thermodynamic coordinate? Gas constant. It is a universal constant. Here, weight of aluminium is half the weight of steel. The last question, students. The amount of energy released when 1 microgram of matter is annihilated. Mass is 1 microgram. Now, energy released. So, E is mc square 1 into 10 power minus 6 microgram 3 into 10 power 8 whole square 1 into 10 power minus 6 into 9 into 10 power 16 or 9 into 10 power 7 joules. But if you observe, see, we are talking about micro 10 power 3 into 10 power 8 whole square. So now we are talking about kilowatt hour. So dividing this by 3.6 into 10 power 6. So 0.25 into 10 power 5 kilowatt hour. So very clearly, a simple paper in comparison. Next, I come up with discussion on 2008 paper. Until then, thank you.